guys, good morning. Hi guys, good morning. This is um, Sir Robert Bamba. Welcome back to our fifth module na tayo, and we will be discussing one of the uh, uh, branch of the mathematics that is actually used in broad applications of information technology, which is the matrix or yung matrices natin. So at the end of this lesson, the student should be able to solve addition of matrices, subtraction of matrices, multiplication of matrices, and solve multiplication of scalar quantity to a matrix. And familiarize common types of matrices used in computer science and data science application. So nowadays medyo sikat na sikat ngayon sa artificial intelligence, data analytics, and data science, no? Actually very few pa yung mga nag-offer actually ng master's or doctorate in data science. And one of the prerequisites is of course the linear algebra, and one of the topic in linear algebra is of course these matrices. So mamaya papakita ko yung give you specific examples para ma-appreciate natin bakit natin aaralin itong mga matrices na to in data science. Actually dun sa Python pwede natin makita yung mamaya. So a matrix is a rectangular array of numbers. So the order or dimension of the matrix is the number of rows and columns that make up the matrix. So actually doon sa last part ng curriculum ng or course content ng Introduction to Computer Programming, which is the Turbo C or C++, meron doon yung huling inaral yung 1D and 2D arrays. So both will actually can be used in representing matrices, yung 1 array tsaka 2D arrays. So row by column sila actually. So mamaya babalikan natin itong mga iba't ibang klase ng papakilala natin iba't ibang klase ng matrices. But in this case, let's start right away dun sa addition na kagad. At may pakita natin ng isang example. Actually, this is an output of matrix. And that is a square matrix. It is an identity matrix in which all diagonals values are 1. Remaining 0. Sige, mamaya babalikan natin mga yan. Skip lang ako right away dun sa algebra of matrix na tayo kagad, or arithmetic of matrices. Okay, may skip ko na kagad. Ang pinapakita niyan, addition of matrices. Okay, ayan, come on. Yan. So, how do we add matrices? And by the way, sabi niya 2-dimensional siya. So, ito yung mga tinatawag nating elements sa isang matrix. We have 4 elements here. The row 1 and row 2 and column 1, column 2. So, ganun siyang titignan ng dimension nito. This is actually, yung position ng tree na to is row 1, column 1. Ito, row 1, column 2. Row 2 column 1, row 2 column 2. So this is a 2 by 2 matrices. So you can add 2 matrices kapag pareho ang size nila. Kung 2 by 2 to, 1 2 1 2, dapat ito 1 2 1 2. 2 by 2 rin dapat ang size niya before you could actually add matrices. So paano ba siya? It's just a process of element by element ang add niya. In this case, yung 3, kamukha niya position, itapat mo lang dun sa position nitong kamukha niyang location point na to. 4. Ibig sabihin, yung column 1, row 1, column 1, i-add mo sa same location na row 1, column 1. This is case 4. So, 3 plus 4, that gives you 7. Ito naman, 8 plus 0 is 8. Tapos ito, 4 plus 1, it's 5. Then 6 plus, but this is negative. So, magsasubtract tayo kapag combining like terms ng algebra. So, subtract natin dalawa na yan. So, that is actually 6 minus 9 is minus 3. So, susundan natin yung sign na mas mataas na value. In this case, it's negative 9. Kaya siya yung sinundan natin ng sign. Kaya negative 3 yan. So, subtract natin, then sundan ng sign ng mataas na value. So, ganun lang siya. So, mapa 3 by 3, 4 by 4, 5 by 5. Basta parehas ang size ng matrix natin. Pwedeng, matrices natin, pwede silang i-add. Dito naman, we have a negative of a matrix also, simple. This is very simple. Actually, meron tong 1 dito. That is actually a scalar multiplier. No? Hindi na lang sinulat dito, negative 1. Ibig sabihin ng negative 1, multiply ko lahat sa elements ng matrix na to. So, this is actually negative 2. And negative times negative is positive 4. And then, ito, negative 7. Negative 10. Take note, in multiplication, same sign becomes positive. Opposite sign, negative. No, yun lang ang tatandaan natin. So, this is actually a scalar multiplication of matrix because actually there's a value of 1 here. So, that's negative 1. So, negative 1 times 2 is negative 2. Negative 1 times negative 4, same sign, so magiging positive 4. Negative 1 times 7, that's negative 7. Negative 10. So, negative 1 times 10 is negative 10. So, that's how we multiply a scalar value. Kung may value 10 yan or 5, so, ganun din ang process. No? O, in this case, negative 1. Kahit hindi sinulat yung 1 dyan. Subtraction, same process lang naman ng addition of matrices. So, dapat nga lang, parehas sila ng sign. No? So, in this case, 3, usually, again, pag subtraction of terms natin, mga elements, unlike sign, nagsasubtract tayo, no? Then, follow the sign of the highest value element. In this case, 3 minus 4, so that's minus 4 is has a higher value than 3, so that's sundan natin yung sign, no? Negative. So, negative 1. 3 minus I'm sorry, same position, 8 minus 0, so that's positive 8. 6 minus negative 9, so in this case, negative times negative muna, magiging positive, so proceed ka ng addition sa 6. 6 minus minus, magiging plus, o magiging 15 siya nun. Ito naman, 4 minus 1, that is unlike sign, negative 1, tapos ito positive 4, subtract, it's 1, tapos mataas ang value nito, kaya positive tayo nun. Sundan ang sign nya. Yan. Multiplying by a constant, ito yung sinasabi ko kanina. You just need to distribute the scalar value of 2 to all of the elements, meaning 2 times 4, that's 8. 2 times 0 is 0. 2 times 1 is 2. 2 times negative 9, it's negative 18. When you multiply two unlike signs, it's always negative. Multiply same sign, positive. Diba? Okay. So, that is actually a scalar multiplication. There is a constant value of 2. So whenever dividing a matrix to another matrix is not straightforward. So you need to perform first what we call the inverse. So A divide B is equal to A times 1 over B, or um, this 1 over B is read as B raised to negative 1. This is the representation of an inverse of a matrix B. So there's a process for this. No? So, but I will just give you the process of solving this by MATLAB, no, of this one, so that we could just skip this process. So I am just giving you the idea of how to add, subtract, and multiply the matrices. In this case, you don't need actually the exact process of this division of matrix. So we'll just do that one in MATLAB in the 6th module. Okay, so let us move on the what you call the multiplication. Yan, multiplying a matrix by another matrix. So this is a process of how we multiply the matrix to another matrix. So, but to multiply a matrix by another matrix, we need to do a dot product of rows and columns. So what does that mean? So we must check first the size of the matrix. So in this case, this is 1, 2 rows by 3. So let's type that one. Let me type that one. So the first row or first matrix has a size of 2 by 3 column. 2 rows, 1, 2, 2 rows, 1, 2, 3 columns. And the other matrix is of size 1, 2, 3 rows by 2 columns, 1, 2. So that's 2 columns. So we must check the middle values of these two matrices. This is an 3 by 3, so dapat both of these are same, and the resulting output would be 2 by 2. So this would be, or this must be of the same. The column size of this first matrix will be the size of the row of the second matrix. In this case, 1, 2, 3. In this case, 1, 2, 3. So we count here for the column and row. It should be the same. Meaning 1, 2, 3. That would be the number of columns for the first matrix, and then in this case 1, 2, 3, we will count the row. They should be the same, 3 by 3. Then you could proceed in multiplying the two matrices. Okay, so the output would be a 2 by 2. So how do we get this 58? So we must proceed of what we call the dot product. So it's where we multiply matching members, then sum up. How's that? The matching members, meaning the same position must be multiplied, or the same element position. For example, 1 times 7 plus 2 times 9 plus 3 times 11. So that's what we mean by that product. Position by position, we add them, we multiply them, then add them up. So just think of this technique: row, then column. 1 times 7 plus 2 times 9 plus 3 times 11. So this is it. So 1 times 7 plus 2 times 9 plus 3 times 11. That gives us 58. And the other hand, so that will be the first element. So we know that the output is a 2 by 2, 2 by 2 size, so what will be the next value? Then the next value is 64, so we still remain on the same row, but we will move now to the next column. So that is 1 times 8 plus 2 times 10 plus 3 times 12. So 1 times 8, 2 times 10, 3 times 12, then we add. Be careful when you have a negative values. It just so happen we have all positive values for the elements of each matrices. Then we can now move to the next row, then multiply it by that product of the first column, second row ulit, and the second column that product na naman. Okay? So we can do the same thing from the second row. Ayun. So we will get the first row, then the first column of the second matrix, or this is the second row, then first column. So then 4 times 7, 5 times 9, 6 times 11, then we add them up. We add them. So how's that? So let's go back to the matrices. 4 times 7 plus 5 times 9 plus 6 times 11. So that will give us the row 2 column 1 element. There we go. Okay. Then next, we do the same thing for the last element. 4 times 8 plus 5 times 10 plus 6 times 12. Then we have this answer 154. In this case, this is 139. So let's try a real life example. A pasalubong seller in Tagaytay sells 3 types of pies. Apple pies cost $3 each, cherry pies cost $4, and blue pies cost $2 each. And this is how many days sold in 4 days. So for Monday, we just set a matrix. For apple, 13, Tuesday, Wednesday, Thursday, so 4 days. So 13, 9, 7, 15, 8, 7, 4, 6. So this is a 1, 2, 3, 1, 2, 3, 4. So this is a 3 by 4 3 by 4 column size of matrix. So the now think about this. The value of sales for Monday is calculated this way. So for Monday, that is 13 times $3. Take note, the values, the cost of each fruit is or are 3, 4, 2 respectively. 3, 4, $2 respectively. 3, 4, 2. So for Monday, we will multiply this by that product for the cost. So in this case, apple pie plus cherry pie plus blue pie, berry pie value. So that is for Monday, we have 3 times 13 for apple pie, then 4 times 8, then 2 times 6. So that's $83 for the Monday. So in fact, this is actually the dot product. So we match the price to how many sold, multiply each, then sum the result. So for the Tuesday, actually, have the same process. So we just need to check. Yes, no, 974. Then the value or 342. So 974 342. So that's $63. Then Wednesday, 342. So let's continue. So nakat lang yung video natin ng Bandicam. Again, for Wednesday, Same price pa rin lagi yan, 342, pero yung sales nilang Wednesday, 7 para sa apple pie, 4 sa what's this, the second fruit, and there's no sales for the Wednesday of that fruit, the third fruit, the blueberry pie. This is the cherry pie, $4 na. And then for Thursday, so proceed with the same, no? This 974, 740, and 1563 are actually the column value of the matrix, right? So column yon. So in other words, we have the size of in summary, we could just perform multiplication of matrices. So this is the cost. These are the costs of the fruits. $3, $4, and $2. Then these are the sales for Monday, Tuesday, Wednesday, and Thursday for the three fruits. So we'll check the size first. This is a 1 by 1, 2, 3. So that is 1 by 3. Then let's check the size of the other one. 1, 2, 3. Yes, 3 by, then 1, 2, 3 column. So hang lang po. Sadali lang. Nag-hang ang computer ko. And let's continue. So this is a 1, 2, 3. So that's 3. 1, 2, 3, 4 column. So here's the size. So let's check the middle values. We have the same values, 3 and 3. So you could proceed actually in multiplying these two matrices. And the resulting size will be 1 by 4. Yeah, it's true. It's 1 by 4. One row with 4 columns. So that's how we multiply matrices. Okay, so we have discussed addition, subtraction, and multiplication. Yung division, we'll just use the software to present all this arithmetic of or algebra of matrices. Okay, because that it was not included in the course outline of our OBTL for the division of matrix. But nevertheless, the process just you need to perform an inverse of a matrix, and I will give you an exact example using the software. Okay, don't worry, and I will give you the other real life applications of this, especially in data science. Okay, so let's move. Before I will give you the special types of matrices, let's go to the Python coding of some data in data science. I think I have searched on a site that will give us a good example of how this matrix is being used in data science. Data science example, you could visit this datascienceexample.com. We can use the techniques of 2D array technique taught in computer programming basic or in ICOM. Yung subject nyo ng ICOM, tinuro yan dyan. In my case, with my students, I have just I think I have included up to 2D, two-dimensional array. I think it's still covered in the next subject. It's data structure or objective programming nyo. But nevertheless, let's go to the example. So NumPy. So what is NumPy? You can actually download the libraries of this NumPy. It is essential libraries in Python. Allows you to work with arrays, and arrays would actually give you a way on presenting and manipulating matrices. So you must import the numpy to work with arrays or matrices, no? Sa Python. So in this case, to start using the numpy, we have here, I hope I could actually magnify this one first, no? Let me pause for a while. Okay, so to import numpy library, so you could actually use this, no? Start using numpy, import numpy as np. Np is the shortened way of typing numpy is np. So first we will start by making a basic list. In this case, it's very much similar to a 1D array, no? So my list, then we have elements, no? We just like we have it's like you have one row, 3 columns, no? So notice how the list in square brackets, it does not require any reference to numpy. Again, the lists are built in Python in data type, no? The lists are built in Python data type. So then to show the list, you can just use print my list. So the name of your array is my list. So actually, you have not yet created the array, no? Pero the next obvious step is to make an array from this from the list command. My array is equal to, you must call this np from the library, np.array then my list. So that will be the time na you already have your array. So if the list is long and you want to know the number of elements in a list, you use this command, print my array dot shape. Yan. Then additionally, you can always print the array, print my array. So I'm just showing you how useful the matrices. In this case, nung na-declare na niya, or how to make the elements or print the elements of an array, so through the use of lists, no? Matrices are actually list of lists. So Python does not have specific matrix data type. However, a list of lists can be used as a matrix, to be a matrix, no? Yan. So i-list lang para maging matrix siya. Ayan, in this case we have list of how many? 3 square braces, meaning this is a 3 by 3, no? So 1 2 4 9 2 2 5 7 3 4 3 2 2 1. So this is, can also be written as this way. So it's very much similar to the 2D array, no, of your C programming. So a matrix can also be made into an array through this process. My array matrix that np array, then call the matrix list, my matrix lists, a list of lists. So these are actually various of lists, list 1, list 2, list 3. Then you just call the library np.array quantity. This is a syntax to convert into an array. So it can actually be, the code can be actually accessed through this site. So let us see. There you go. So here's the code. Ayan. So import numpy as np. So you create list first, then if you want to display this list, print my. Okay, so we have use already the 10 minutes video for Vatican. Okay. So in this case, it calls the my list to be a list. It's not yet an array actually, no. So tinawag muna siya sa NP library. So then magiging convert na siya ng my array. So print my array dot shape. Then my list naman, eto sila, panibagong data na naman to. So you could actually combine the numerical values and strings, no? But the problem is you will have an error because of the data type. The first item in array is %d, then there's a different array type here. But in this case, if you will use string, it will not cause an error because of these values. Alex, Stevie, and Tom and Cool are actually strings. So matrix made of list of a list. Ayan. So you declare first your list before you could actually tell that it is already an array. So this one is a more readable form of this one. Then print my matrix, then it will actually first item in array. Okay. So just to give you a hint on why do we study the matrix for computer science, no? Or IT, because nowadays in a huge data storage and data analytics and especially in AIs, so math plus computer programming is are the tools you need, no? To be part of that field of specialization. Okay. So that will be, I think, for this module muna. Then we will go to the MATLAB software to solve the algebra of matrices. Okay. So, but by the way, I need to give you another video link for, aside from this Python matrix technique. I think I would like you to see in real life application in terms of encryption and decryption using matrices. So let me pause for a while and find the video.
In this video, I'm showing how to use matrices to encode and decode messages. And I'm making the assumption when I make this video that you know how to multiply matrices already and that you've had some experience using a graphing calculator to do that. So that's how I will be multiplying the matrices. If you need some help with that, I have a video on using the graphing calculator for multiplying matrices right now, but I don't want to try to code that in some way that they could see see some characters, but maybe nobody else would really understand. So here's one option, I suppose. I'll just put letters with it. Okay? And I've used this this alphabet listing over here on the right side. 19 goes with the letter S. 5 goes with the letter E. 12 goes with the letter L. 0 for space, and then N-O-W. And you might be realizing correctly that that's not a very effective code. It's not going to take someone very long to figure that out. So here's what I'm going to do. I'm going to kind of mess up that code a little bit so that it's harder to understand. Okay? To do that, first I'm going to take my message matrix, or my message string, and write it in a matrix this way. Now still, that's pretty easy to understand. But here's what I'm going to do. I'm going to multiply it by a 2 by 2 matrix out here, and I'm going to randomly choose some numbers here that will make this, when I do this matrix multiplication, it's going to be harder to understand. Okay? Now, I happen to choose these numbers somewhat carefully just because I know later on I'm going to need to use the inverse of this matrix, and I'll show you what I mean by that. So let me do this multiplication first. I'm going to take this and move it out of the way just a little bit so I've got some room to work. And now I'm going to grab a graphing calculator, the TI-83 Plus, and I'm going to use this. We'll turn it on, clear that, and I'm going to call this matrix A right here and matrix B there on the calculator. So here I go. I'm going to go to matrix and edit matrix A. So I'm on matrix A already, so I'll press enter. It's already a 2 by 2 matrix, so I'll go on from there. And so I'll just enter 3, 5, 1, 2. And there's matrix A. Notice I pressed enter after every number. Okay, quit out of that. Now I'm going to go to matrix and edit matrix B, so I can press 2 now. Now I'm editing matrix B, and it's a 2 by 4 matrix. I have some other numbers in there. We'll cover those up here as we go along. So this is 19, 12, 0, 15. Okay, now I'm down in the second row, 5, 12, 14, 23. Okay, so I have all those entered in there, including pressing enter after every number. So I'm going to quit now, and now I simply need to multiply matrix A times matrix B. So matrix, I'll stay on names up here and press enter, and matrix again, stay on names and press 2. So not putting a multiplying sign in between there is okay. The calculator understands that when they're side by side, I want them multiplied. So here I go. There's the new matrix. Okay, so I'll write that down over here. 82, 96, 70, 160, 29, 36, 28, and I'm going to see if I can make a copy of this and copy it to a new screen right over here. Okay? And I'm going to pretend that I just got that matrix. Okay? I just received it, okay? And now I'm going to decode it. Okay? But I need to know, hey, what was that original coding matrix? So let me go back and look at that. That was 3, 5, 1, 2. Or if you like to read down, 3, 1, 5, 2. I'll do that. 3, 1, 5, 2. Okay. So here it was. 3, 1, 5, 2. That was my coding matrix. Okay. Well, now what I need to remember is this. The person that sent this message to me took that matrix, multiplied it by some original matrix right here, or some message matrix, okay, and got this blue one. Okay? So I need to unmultiply by my coding matrix so I can find out what the original one was. Okay? And the way we do that is we take the inverse of this matrix and multiply it right here. Okay? So you might remember how to do the inverse of a 2 by 2 matrix. We took the two numbers down the main diagonal and switched them, 2 and 3. We took the numbers on the secondary diagonal and made them the opposite. And then we divided every number down here by a number we got by multiplying these two together and multiplying those two together and then subtracting those. So that was 6 minus 5. So we would divide by 1. Okay? So dividing by 1 doesn't change anything. So now I've got my coded matrix right here in blue, and here's my decoding matrix. Right there. Okay. So let's do that multiplication now. Okay. So let me remember here. This 14 goes with when they multiply them to 15 goes with n, 15 goes with o, and 23 goes with w. Okay. So I've now decoded that matrix with that message so I can tell what it said. Okay. So suppose I get this message string. 5 goes with E, 12 goes with L, a 0 is a space, and 14 goes with N, 15 goes with O, and 23 goes with W. So I've now decoded that matrix with that message so I can tell what it said. Okay. So suppose I get this message string come across the wire somehow, and it doesn't make any sense to me, but I do know that I previously agreed with the person that was sending it to use this coding matrix. So whatever that person did, whatever message it was, when they multiplied them together, okay, they got this matrix here. And what we agreed on before was that we would write them in vertical order like this. This matrix right here. Matrix B is this, and what I really want to do is multiply the inverse of matrix A times B. Well, the calculator can do that for me. Let me step over here and get matrix A. I have that entire matrix typed in there, and I'll remember that that is matrix B. Okay. So let's review what I've got here. Matrix A is this.
And guys, so I have shown you two examples of real-life applications of the matrices algebra, no? So encoding, decoding, or encryption, decryption of data, and likewise in Python, and manipulating data in data science examples, no? Or in a data analytics situation. Okay guys, so okay, so yan lang po ang ating cover ng module 5. So ang question naman is actually more on titest lang naman yung background kung check kayo kung alam nyo paano lang mag add, subtract, and multiply ng matrices. But actually those are just techniques in long method. Ang ginagawa ko usually pagdating sa mga math subject ko ay pag estudyante ko IT sila, so I make sure to present them in a software method naman. Like for example sa statistics, tinuturo ko sila ng SPSS, no? Likewise again also dito sa ating discrete math, you could actually use a software also. What we call the MATLAB. So see you guys in the next module, and I will show you on how to use MATLAB to manipulate matrices or to solve algebra of matrices. Okay, see you.